Welcome to another tutoring session with Ms. Taylor. Today we are looking at a kinetics problem. In this one they have given you three graphs and you're supposed to use those graphs to give yourself some information. So in this problem they have given us the balanced chemical equation, told us that this is 25 degrees Celsius, not really a big deal. But our first question is, what is the order of the overall reaction, and justify your answer. So what you are supposed to be looking for is the straight line graph. And in this case, this one is our straight line graph. And because we see that the natural log of A is on the y-axis, we know that it is first order. And your justification simply has to say that because the graph of the natural log of A versus time is a straight line, it is a first order reaction. Now, what if it would have been the concentration versus time? Then that would have been 0th order. Or if it would have been the inverse of concentration versus time to get a straight line, then it would have been 2nd order. Okay. So then the next question is, what is the rate law for the overall reaction? Well, since it's first order and we only have a single reactant up there in our balanced chemical equation, it is simply rate equals K times the concentration of A. And if you want to write in the 1, you can, but it's usually understood that there's a 1 there. All right, I'm going to scroll this down just a bit. So the next question is to calculate the rate constant K for the reaction at 25 degrees Celsius. Okay, they gave you a hint on this one. So for C, we are going to use the integrated rate law for first order reactions, which is given to you on the equation sheet for AP Chemistry. I'm writing that equation right now. If you come to the AP Chemistry exam and you cannot remember which graph is supposed to be what, here's a little hint. Okay? On the AP Chemistry formula sheet, under kinetics, there's only 3 equations. The first one is this, first order. The second one listed is the second order equation. The third one is obviously half-life because it says T half equals. But notice what is on the y-axis and what's in our first order integrated rate law. ln of A, ln of A. If you look at the second order integrated rate law, it's similar in form, but it's the inverse of A minus the inverse of A equals positive KT. So, second order, the second equation, notice what's on the y-axis. Hey, any little thing we can use to help us make more points is what counts. So on this one, it looks as though our initial natural log of A value is negative 3.2. And the time we are going to go to is 90 seconds. And then it is negative 4.2 at that point. I will pause for a moment to punch this into my calculator. And so you subtract those two and divide by negative 90, and your K value should come up to be 0.011. And then the units, very specific on this. Since this is first order, we know that the units have to be in seconds. Now the reason why we know that it's supposed to be in reciprocal seconds, I'm going to look back at our rate law. Rates are always supposed to be positive, and the rate is always supposed to be in molar per second. And rather, I should say molar per time unit. And in this case, it was seconds, so the rate for R should be in molar per second. So then you say, okay, well, we already know, since this is first order, that this is molar. We need this to be molar per second. K has to be reciprocal seconds in order to get that. And you can do that same thing with other rate laws to work out the units for K for second order and third order. Alright, so our next question, part D, is what is the half-life for this? Well, now that we have K, we can do this fairly simply. Switch back to columns. Alright, the third equation on your equation sheet is the half-life equation. It's 0.693 divided by K. So since we have our K value already, pop that into our calculator, and we get 63 seconds. Now, you could also find this by estimating values on your graph, but this is a whole lot easier. And then the last thing they want you to do is to calculate the value of A when 150 seconds have passed. Well, now that we know our value of K, and we have our initial concentration, we can just plug in and solve. Minus negative 3.2 is negative 0.011 times 150 seconds. Alright, now I'm going to write out the algebraic steps for you because you may not know how to solve a natural log. Let's shorten this down just a little bit. Okay, so I'm going to combine my like terms. I'm going to change that minus and negative to plus and positive. And then negative 0.01 times 150 gives me negative 1.65. Then I'm going to subtract 3.2 from both sides. Natural log, I just noticed I wrote the 10 inside the outside. This is going to give us a negative 4.85. Alright, here's the tricky thing. The way we undo a natural log is we raise that number to, or raise e to that number. So this is e to the negative 4.85. Plug that in our calculator, and we get 7.8 times 10 to the negative 3 molar. And that concludes the problem. Thanks for watching.